In today's video, I'm going to explain why I divide by 4 in my table format for graphing. So I have this trig function here. So y equals 4 times sine of 3 times x minus pi over 3 plus 4. Okay, and I have a table already set up in the columns, my x values that I want to start with and want to get to in the beginning, so I can graph those nice numbers already put in there. So kind of going through this, and we've talked about all these things kind of together already, but in this process, we always get to the third column, which is the 3 times x minus pi over 3 column. And then we do this division of 4 when we're talking about a period. So like for here, for the second column, let's just try to get there. So I would say pi over 3 for that first column because I want to get, I want to plug something in that's the opposite of minus pi over 3 so that when I subtract it, I get back to 0. And remember, we don't care about these other numbers in the second column because they don't relate to the period values in the third column. So I don't write them because I don't need them, okay? So that pi over 3 is the first value that so phase shift continues to be the starting value for the third column, but now I need to figure out what my new period is. Because up here, I have a k value that is not 1, right? So if you've noticed before, I don't do the division of 4 with some trig functions or some trig graphs. It's because those graphs have a k value of 1, so I don't need to. These values that are in my first column, don't need adjusting for interval wise, so I don't need to do this or do this part. So, but my k value in this case is 3, so I'm going to be forced to do that. So if you think about period, I've given you the ratio that is 2 pi over k, and because they gave me a k value of 3, that means I need to plug it in, okay? And so when I plug that in, I get 2 pi over 3 as my new period value, okay? So new period, I need to figure out how this is broken up, okay? So this is where that division of 4 happens that we kind of want to be able to talk about. So I would divide by 4 here because this is my period. Divide by 4 means 2 pi divided by 3 gets me 1/4. That's 2 pi over 12, which is pi over 6, okay? And I've been calling this my interval value, okay? So why do I do this, okay? Basically, why is that a thing, okay? So let's go over to the next screen. I have already graphed sine and cosine as parent functions, okay? Now when I'm looking at these, okay, you have these particular values that we've graphed and we've talked about where they have nice, neat values of graphing, right? You have 0, pi over 2, pi, 3 pi over 2, and 2 pi. They happen for both sine and cosine. They have different values of y at those points, but they have the same x values where those nice numbers happen, which is very convenient. Okay, so what I want to kind of show you is what is happening here. So let's take sine first. So looking at sine, you have it starting in the middle, going up to its maximum, back to the middle, going to its minimum, and back to the middle. Then that's one complete cycle, okay? Now, if you were to draw like lines through those critical points, those nice values on your graph, you would be able to break up your graph into equal parts. Because if you've noticed, each of these values are actually the same distance away from one another without even having to do anything, right? So I'm just drawing vertical lines to kind of divide up my graph into those portions, okay? So you can kind of think of this in your quadrants, right? So here, this first one right here, so like from 0 to pi over 2, that's 0 to 90 degrees, right? So that's the first quadrant, okay? Then from pi over 2 to pi, notice that that's like 90 degrees to 180. Those are values in your second quadrant, right? Then from pi to 3 pi over 2, that's 180 to 270. Those are values in the third quadrant. And then from 3 pi over 2 to 2 pi, which is 270 to 360, those are values in your fourth quadrant, okay? So notice that each section or each quadrant is 90 degrees big, or pi over 2 big, compared to one another, right? They all have the same distance, so they're all equal parts. Think about how many quadrants there are, how many sections. There's 1, 2, 3, 4. So because there's 4 sections, that is where that number is coming from. And so anytime I'm looking for, like, looking at my table, so if I have to go back, looking at this graph here, I want to know where those values, those nice numbers are going to land, and they're going to land at equal distances from one another because you're plugging in these values in this first column essentially, okay? Because when I get to, like, if you're just looking at sine of 3x or 3 times x minus pi over 3, before you get to, whenever you do the sine, whatever this thing is, like whatever we plug in for x for the 3 times x minus pi over 3, that's going to end up being this number right there. And then the next one's going to map back to pi over 2. The next one's going to be pi. So they're all those equal portions away from one another. So the reason I divide by 4 is to get these nice numbers so they land on those lines that I've sectioned out already in this section, or in sine and cosine. So I can do the same thing for cosine too. I can take this, let me get a good color here. So break them up. Okay, see, if you look here, there are 1, 2, 3, 4 sections, and they're all equal amounts away from one another. They're all that big. If you made them into rectangles, they're all equivalent rectangles. They all have the same area, if you think about it that way. So I'm just breaking my graph into equal sections so that when I look at, because this is from here to here, that is pi over 2. That's an interval right there. That's why I use the word interval so often, is because I'm looking for this equal interval so that when I add from my starting position, which would be right there, and add it to the next, I can get to that point. And then I add to the next, I can get to this point. Add to the next, get to that point, add to the next, get to that point. So I'm not looking at the y value. I am strictly looking at what the x distance is across one cycle so that I can get from start to start. And I can map that equally and look at it like in the same fashion as you would the parent functions of sine and cosine. Okay? So like going back to this one, if let's erase this real quick. So now let's kind of find what we're doing. So we said that we divided by 4. That put 2 pi over 3 and divided it into equal sections of an interval of pi over 6. So that means if I was to take pi over 6 and add it to itself 4 times, you would get 2 pi over 3, because that's the distance from start to start. So you're looking at one cycle of sine or cosine, in this case sine. So if I was to take pi over 6 and add it to pi over 3 up here, pi over 3 is 2 pi over 6. So adding a 6 gets me 3 pi over 6. Then another one, 4 pi over 6, 5 pi over 6, and 6 pi over 6. Okay, and if it helps, we can make our table look like this too. Okay, so that 2 pi over 6, when I plug it in, should map me back to 0. That 3 pi over 6, when I plug it in, should map me back to pi over 2. 4 pi over 6 should map me back to pi. 5 pi over 6 should map me back to 3 pi over 2. And 6 pi over 6 should map me back to 2 pi. Okay? And if you need to, that's why we plug them in, because I want to be actually able to see and make sure that I did this correctly. So that's why I always kind of show this step. I know, yeah, can we assume? Yeah, for sure. You can always assume stuff. But most of the time when you assume, it doesn't make you look very good, unfortunately. And then you get the wrong values, and then your graph is all wonky because you're actually not graphing the right graph. So here I would plug in 2 pi over 6. So 2 pi over 6 minus pi over 3. And actually, we could probably make these all 2 pi over 6 just to make sure that we're subtracting correctly, so we don't have to worry about common denominators or anything. Okay, so 2 pi over 6 minus 2 pi over 6 is 0, times 3 is 0. That maps me back to my original point. So sine of 0 should be 0. Okay? Oh, my bad. It goes in here. I just don't have enough room. 3 pi over 6 minus 2 pi over 6 is 1/6. So 1/6 times 3 is 1/2. There's pi over 2. Okay, so then sine of pi over 2 is 1. Okay, then 4/6 minus 2/6 is 2/6 times 3 is, so 6/6, which is 1. So there's your pi. Sine of pi is 0. Then I plug in 5 pi over 6. So 6 minus 2/6 is 3/6. Times 3 gets me, 3, 3/6 is 1/2. That's where I was thrown off. And then times 3 gets me 3/2. So 3 pi over 2 gets me -1. And then 6/6 minus 2/6 gets me 4/6. And then that gets me 2/3. And then 2/3 gets me 2 pi. okay? Sorry about that, all those fractions. So then that gets me back to 0. So therefore, I'm trying to get those nice numbers, which all of those values that I put in did. Okay, so just remember, reiterating here, when I'm doing my table, I am trying really hard to get nice numbers like this in this 4th column. If I'm not getting nice numbers, then you either weren't worried about getting nice numbers, which is fine. You can totally graph these graphs without having to do this big, long, complicated table. I know this table is kind of hard, but its only purpose is to help you graph nice numbers so that you can get a good looking graph. So your graph is made easy for you. That's it. That's its only purpose. If you're not worried about that and you're going to kind of have to decipher where your points are because they're not going to land nicely, then go for it. You just plug in x's, these starting ones, plug them in, and then see what happens, okay? Because you'll still get a graph, it'll just be harder to decipher where your mins and maxes and where it crosses your x-axis. That's basically the only difference. So here I know exactly where my max and mins are, I know where my x-intercepts are, and then it's easy to graph, and it makes the scale easy to draw too. So that's the purpose of the graph or the table, okay? But I can continue here. 0 times 4 is 0. 4 times 1 gets me 4. And then I get 0, -4, 0. And also makes all these other steps super easy. So I know there's a lot of upfront work, especially to get to that 4th column. But then afterwards, doing the simple steps of like multiplying by the amplitude and then adding or subtracting the vertical shift makes life so much easier when you're trying to graph a graph. Okay? So that's why we divide by 4, is because we're trying to break this up into nice, even sections that are just naturally happening in your sine and cosine graphs. That's it. Okay? Let me know if you have any more questions. Thanks.